3 specific construction methods produce recreational vehicles that last 20 years or more, and the industry does not want you to know about them because they prove that planned obsolescence is a choice, not an engineering limitation. While volume manufacturers are selling you disposable boxes designed to fail after the warranty expires, a small group of builders are using materials and techniques that create machines capable of multi-decade service. These are not luxury features. These are not premium upgrades. These are fundamental construction philosophies that separate tools from toys. We are going to expose the 3 construction types that mechanics drive, the engineering principles that make them indestructible, and show you how to identify these builds before you waste money on garbage designed to self-destruct. The recreational vehicle industry has spent decades conditioning buyers to accept that these units are temporary products with 7 to 10-year lifespans. They argue that the vibration, temperature swings, and road stress make long-term durability impossible. This is corporate propaganda. The truth is that construction methods exist right now that produce recreational vehicles lasting 30, 40, even 50 years with basic maintenance. These methods cost more to execute, but the total cost of ownership is lower because you are not replacing the entire unit every decade. The volume manufacturers reject these methods because they conflict with the business model of repeat purchases and planned replacement cycles. The longevity gap is staggering and documented. Owner communities track the lifespan of different construction types, and the data is undeniable. Molded fiberglass trailers from the 1970s and 1980s are still on the road with original owners. Aluminum riveted trailers from the 1960s are being passed down through families. Welded aluminum frame units from the 2000s are approaching 20 years with minimal repairs. Meanwhile, stick and tin trailers from volume manufacturers are being scrapped at 7 to 12 years because of structural rot, delamination, and frame failure. The difference is not age. The difference is engineering. Construction type number 1 is the molded fiberglass shell. This is the Airstream of the travel trailer world, except the fiberglass egg designs predate Airstream and will outlast everything the volume manufacturers produce. Companies like Scamp, Casita, Escape, Bigfoot, and Burrow build trailers using 2-piece molded fiberglass construction. The upper shell is molded as a single piece. The lower shell is molded as a single piece. They bond together at a single horizontal seam with marine-grade adhesive. There are no vertical seams where walls meet roofs. There are no corner joints where different panels connect. The entire structure is a continuous shell. The engineering advantage is elimination of leak points. A traditional stick-built trailer has hundreds of potential water intrusion locations. Every seam, every corner, every window, every vent, every door creates an opportunity for water to penetrate. The manufacturers seal these points with caulk, tape, or sealant that degrades under UV exposure and temperature cycling. Within 3 to 5 years, the seals fail and water gets inside the walls. The wood framing rots. The walls delaminate. The structure fails. The molded fiberglass shell eliminates 90% of these leak points through geometry. Water cannot penetrate what does not exist. The material properties of fiberglass provide the second advantage. Fiberglass does not rot. It does not rust. It does not absorb moisture. It maintains structural integrity across temperature ranges from sub-zero to extreme heat. When properly laid up with adequate resin content, fiberglass becomes stronger over time as the resin continues curing for years after initial production. A 30-year-old fiberglass shell can be stiffer and more durable than the day it was built. Compare this to wood framing that weakens from moisture cycling and vibration stress. The fiberglass shell is a permanent structure. The wood frame is a temporary structure. Owner data proves the longevity advantage. Scamp trailers from the 1970s are still camping every summer. The fiberglass shows no cracking, no fading beyond cosmetic surface oxidation that polishes out, and no structural degradation. The original windows still seal. The original door latches still function. The only components requiring replacement are appliances and soft goods like mattresses and curtains. A 45-year-old Scamp needs a new refrigerator and new upholstery. A 7-year-old Keystone needs new walls, new floors, and new framing because the structure rotted from water intrusion. The cost analysis destroys the industry argument that fiberglass is too expensive. A new Scamp 16 costs approximately $24,000. A comparable size stick-built trailer costs $18,000. Over 20 years, the Scamp owner spends $24,000 plus $3,000 in appliance replacements and maintenance for a total of $27,000. The stick-built owner buys the first trailer for $18,000, replaces it at year 8 for $22,000, and replaces it again at year 16 for $28,000 for a total of $68,000. The Scamp owner saves $41,000 by buying once instead of 3 times. The fiberglass is not more expensive. The fiberglass is dramatically cheaper when measured correctly. Construction type number 2 is the aluminum riveted shell. This is the Airstream method, and it produces the only mass-produced recreational vehicles with documented 50-year lifespans. Airstream builds on a fully welded aluminum frame with hand-driven solid aluminum rivets attaching aluminum panels to the structure. There is no wood anywhere in the exterior shell. The frame is aluminum. The skin is aluminum. The roof is aluminum. Water cannot rot what does not exist. The aluminum riveted construction creates a monocoque structure, where the skin contributes to overall strength rather than just acting as weatherproofing. This is aircraft construction applied to recreational vehicles. Each rivet is a structural fastener, not just a cosmetic attachment. When properly installed with bucking bars and correct rivet spacing, the aluminum skin becomes part of the load-bearing structure. The trailer distributes road stress across the entire shell rather than concentrating forces in a few framing members. This is why Airstreams from the 1960s are still structurally sound, while stick-built trailers from 2015 are falling apart. The maintenance requirement for aluminum riveted construction is minimal but specific. Aluminum expands and contracts with temperature changes more than steel or wood. If the rivets are not installed correctly, they can work loose over time and create leak points. This is why older Airstreams sometimes develop weeping rivets, where water seeps around the fastener. The repair is straightforward. Drill out the old rivet, clean the hole, and install a new rivet with proper sealant. The cost is $5 per rivet and 10 minutes of labor. Compare this to repairing delaminated walls on a stick-built trailer, where you are removing entire sections of exterior and rebuilding the substrate at $8,000 to $15,000 per wall. The Airstream brand has been compromised since Thor Industries acquired them, but the fundamental construction method remains superior to anything volume manufacturers produce. A 2015 Airstream built before the Thor quality decline will outlast a 2025 Grand Design or Keystone by 20 years. The aluminum does not care who owns the company. The rivets do not care about quarterly earnings targets. The physics of monocoque construction do not change based on corporate ownership. If you can find a pre-Thor Airstream in good condition, you are buying a platform engineered for multi-decade service. The alternative to Airstream is the handful of boutique manufacturers still using aluminum construction. Living Vehicle builds custom aluminum trailers designed for off-grid living with fully welded aluminum frames and aluminum composite panels. These units cost $300,000, which prices them out of reach for most buyers. But they represent the pinnacle of what aluminum construction can achieve when engineering takes priority over cost reduction. A Living Vehicle will be camping in 2060, when current Keystones are sitting in landfills. Construction type number 3 is the composite panel system with welded aluminum framing. This is the method used by manufacturers like Oliver and Escape for units designed to last 30 years or more. The frame is fully welded aluminum tubing with no bolted joints. The exterior walls are fiberglass composite panels laminated to close cell foam insulation with structural adhesives. The roof is a single-piece fiberglass panel with no seams. Every component is designed for permanent installation rather than serviceable replacement. The welded aluminum frame provides the foundation for longevity. Bolted frames eventually loosen from vibration. The bolts back out. The joints develop play. The structure flexes and cracks. Welded frames eliminate this failure mode. Once the aluminum is welded, the joint is permanent. The frame becomes a single, continuous structure that distributes stress across the entire assembly. Oliver and Escape use robotically controlled welding to ensure consistent bead penetration and strength. The frames are overbuilt by volume manufacturer standards with wall thickness double what you find in Keystone or Forest River products. The composite panel construction eliminates the delamination problem that destroys stick-built trailers. The fiberglass skin is laminated to foam core with structural epoxy adhesives rather than contact cement. The bond is chemical rather than mechanical. The adhesive actually becomes part of the material structure through cross-linking. Once cured, the panel is a single monolithic component. You cannot separate the skin from the core without destroying both. This is why Oliver trailers do not delaminate. The failure mode does not exist in the material system. The assembly process for composite panel construction is slower and more expensive than stick building. Each panel must be precisely cut, the edges must be sealed, and the panels must be bonded to the frame with specific cure times and temperature control. Volume manufacturers cannot use this method because it conflicts with their requirement to produce 50 to 100 units per day. The composite panel method produces 2 to 5 units per day. This is why Oliver has a 12 to 18-month waiting list. They are building trailers the right way, and the right way takes time. Owner data for composite panel trailers shows repair costs averaging $400 to $800 over the first 10 years. The most common repairs are appliance replacements and worn suspension components like shock absorbers and spring bushings. Structural repairs are nearly non-existent. The frames do not crack. The panels do not delaminate. The seals do not leak. The units age like tools rather than disposable consumer products. A 15-year-old Oliver looks and functions like a 3-year-old Keystone, except the Oliver is paid off, and the Keystone is underwater on financing. The industry hates these 3 construction types because they prove that planned obsolescence is unnecessary. When buyers discover that fiberglass eggs, aluminum riveted shells, and composite panel systems last 20 to 50 years, they start asking why stick-built trailers only last 7 to 12 years. The answer is that stick-built trailers are designed to fail so manufacturers can sell replacements. The wood framing is deliberate. The laminated walls are deliberate. The inadequate sealing is deliberate. These are not engineering limitations. These are business decisions. The protection strategy is to stop shopping based on floor plans and start shopping based on construction methods. The floor plan does not matter if the walls are rotting and the frame is cracking. You can always modify the interior layout. You cannot modify the fundamental structure without rebuilding the entire unit. Prioritize construction first, features second. A basic fiberglass egg with a porta potty and a camp stove will serve you better for 20 years than a luxury stick-built fifth wheel with residential appliances that is worthless after 7 years. If you cannot afford new units using the 3 longevity construction types, buy used from these manufacturers. A 20-year-old Scamp is a better investment than a 2-year-old Forest River because the underlying structure does not degrade. The fiberglass is as strong at 20 years as it was at 2 years. The same cannot be said for wood framing and laminated walls. Age becomes an advantage rather than a liability when you buy construction types that do not rot or delaminate. The recreational vehicle industry will continue producing disposable units as long as buyers accept 7-year lifespans as normal. They will continue using the cheapest materials and the fastest assembly methods because the market rewards low purchase prices over long-term value. But the 3 construction types we exposed today prove that another path exists. Molded fiberglass shells, aluminum riveted structures, and composite panel systems with welded frames represent engineering for longevity rather than replacement. Support manufacturers using these methods with your purchase dollars, and maybe the volume producers will be forced to compete on quality instead of payment terms.